This video will cover the Sorites Paradox. Throughout history, many have attempted to answer questions with similar fashions to how many grains of sand does it take to make a heap? Although we know a heap of sand when we see one, how do we go about putting a number to it? Well, it is obvious that 1 grain of sand does not make a heap. What about 2? The answer is no, because 1 grain of sand does not make a heap. Therefore, neither does 2. This imaginary heap starts adding up until we get to a very large number. However, this large number of grains does not make a heap because this very large number we came up with -1 does not make a heap. Therefore, this large number of grains we came up with does not make a heap, although it follows the same chain of inference. This introduces us to the Sorites Paradox. Although many have attempted to solve this, to name a few: Epistemicism, denying bivalence, and fuzzy logic. Let's start with the concept of epistemicism, which is the concept that draws a sharp distinction between categories such as heaps and non-heaps. While it might sound like a simple and clear solution, this does not make a sharp line. This idea of sharp line is nothing but a reliance on common sense as to where the line belongs, making the answer very subjective. Another approach to this problem is the concept of denying bivalence, which adds another element of answers to a given problem, and that is indeterminate in between the simple truth and false. Although a step up from epistemicism, it is counterproductive in constructing a truth probability, which has a linear relationship with assertiveness and probability of truth. And assertiveness is something that denying bivalence fails to provide. At last, the concept of fuzzy logic comes into play. This is the best out of the 3 concepts we have and will talk about, in my opinion. This concept does not rely on strictly binary cases. Rather, it provides a degree of confidence in whether something is true or false, given that 0 means completely false, and 1 represents the complete truth. For example, let's put, is it cold outside? This fuzzy logic machine as the declarative statement. That machine would determine whether it is very cold on the far left, a little cold left to the middle, and very less cold closer to 0, closer to the middle. This provides a sufficient system to declare probability of truth expressed in numeric form, given in decimals between 0 and 1. This machine can give us incremental answers rather than the strict true and false, which gives the opportunity for us to declare whether something is closer to the truth than it is false, or vice versa, which makes it stand out from the other 2 approaches we spoke about. This is all I have to share for today. Thanks for listening.